Okay. This one's usually pretty good. That one's never done that one to me before. Yes. Okay. So let me look at the question again. So achievement, pre-treatment achievement will predict the change in ADHD scores. So analyze regression, linear. And then what's our dependent? ADHD difference. And what's our independent? Good. Pre-treatment achievement. And that should be it. Okay. Why not go down? There we go. Okay. Good. So is it predictive? No. And just FYI, in case y'all are interested, we talked about in regression that the prediction is on a line, based on a line. So it's kind of like if this is what you're predicting, the change score, and this is what was our predicted achievement? It basically takes what your achievement score is and says, oh, if this is your achievement score, we think, this is what your change score will be. It's kind of like this. And if it's predictive, it falls in the line, roughly. And then you could draw the best fitting line. That constant that you keep seeing with a significance is where that line hits the y-axis. And so that significance test tells you, is the place that the line hits the y-axis significantly different from 0? Most of the time for us that means nothing, because our scores are not standardized around 0, so it doesn't mean anything to us. But for some people in some fields it might mean something, but that's why we ignore it, because it doesn't matter to us.
Analysis was exactly the same, then I have different numbers.
Did you not round and we rounded, or did you round and I didn't round? Did I not round achievement? Anybody else? Because you did achievement difference and we did ADHD difference, right? Did you do ADHD? Yeah, you have achievement difference. You're supposed to be checking our phone.
No, I'm sorry. Dropping the ball here. I looked at it, I was like, that looks right. I just saw difference.
Okay, now did you get something?
Yes.
Okay, good. Okay, and how about our last one? This one is a new one. I haven't shown you this one yet. That's why you're having trouble figuring it out, maybe? Okay, so first thought is probably that it's a correlation, but why do we know it? How do we know it can't be a correlation? Because you can't do categorical. Gender's a categorical, and let's look at treatment. Is treatment continuous or categorical? Well, it depends how you measure it. How did we measure? We measured treatment length in categories. They were either in treatment for 3 months, 6 months, or 9 months. So that's a category. Okay. So if you have two categorical variables and you want to know if they're related, any guess? No. T-test is 2, but t-test is 2 groups, not 2 variables. It is 2 variables too, but and t-test is if you have an independent variable that's categorical with 2 groups and a dependent variable that's continuous. And the question is a difference in the t-test. Chi-square. Chi-square. I know, we hadn't done that one yet. Chi-square. So here's what's funny. My daughter came home and they're doing stat stuff in her math class. And she kept saying, Mama, I don't understand that chi thing. I'm like, I don't know what you're talking about, baby. She's like, don't you teach statistics? I'm like, yeah, but there's no such thing as a chi. Right. And finally she showed it to me. I'm like, baby, that's chi-square. I don't think that's how my teacher's saying it. I'm like, you better listen again. I bet she's saying chi. Right. Right. Yeah, so chi-square is if you have two categorical variables. And chi-square, you'll see, you can either ask about a difference or a relationship for chi-square, but it's if both of your variables are categorical. Yeah, because if they don't have levels, then they're not variables. Then they're constants. Okay. So this one's a little odd to get to. So analyze descriptives. Did I start the video? Do y'all remember? I think I did. Analyze descriptives, crosstabs. Okay, y'all there? Everybody there? Analyze descriptives, crosstabs. And then over here, hit statistics and check chi-square. Okay, so here, I'll do it again. I hadn't put anything yet. Not age, treatment length. So let's do it. It doesn't really matter what you put in rows and columns, but let's do it the same way, because if not, our people's charts will just look different. So put gender in row and treatment length in column. Okay. Chi-square is if you have two variables that are both categorical. And people, you can use either the word relationship or difference. Okay, and did everybody hit statistics and chi-square? And press continue. So we're gonna run it this way first, and I want you to look at the results, and then I'm gonna go back. We're gonna add some things in after, but I don't want to overwhelm you on the first draft. It's like too much information if you put it in at first. I just want you to look at it this way first, and then we're gonna come back and add some stuff. Okay, press OK. Okay, so it gives you a little chart telling you how many females were in therapy for 3 months. Ooh, excuse me. How many were in treatment for 6 months, how many were in treatment for 9 months, and then same thing for males. Okay, and it gives you your totals. It kind of looks like what we were doing a little while ago with our factorial charts, except in our factorial charts, the numbers in the columns were like a continuous score on the dependent variable. These are just frequency counts. Okay, and then there are 3 different statistical tests that SPSS will automatically run for you for chi-square. Most people will use the Pearson chi-square test. Sometimes you'll see the likelihood ratio. I don't know that I've ever seen this last one reported. But for our class, just go ahead and report the Pearson chi-square analysis. So you'll report, in order to test the hypothesis that those two variables were related, a chi-square analysis was run. Results were what? Not significant. Open parentheses. Chi-square, it's okay if you want to just type out chi-square, but if you go into Word fonts and you pick symbols, you can get the little chi-square symbol. But if you don't want to do that, you can just type out chi-square. So chi-square, little subscript, open parentheses, 2, close parentheses for your degrees of freedom, equals 0.836, comma, p equals 0.66, close parentheses period. In order to test the hypothesis that there would be a relationship between gender and length of time spent in treatment, a chi-square analysis was run. Results were not significant. Open parentheses, chi-square, or you can write out chi-square if you don't want to get the little symbol. Then little subscript for the degrees of freedom equals, what was our chi-square equal? They don't like your answer. Yeah, you get so 0.836. P equals, what is it? 0.658, 0.66. For now, no. Just put significant and then leave it at that. And then with this, you can kind of look at the chart and interpret it. So let me go back. I'm going to give you show you how to get the additional information that kind of helps you look at it just gives you a bunch of percentages. Okay, so go back. We're going to do the same thing. Analyze descriptives, crosstabs. Okay, so we're back here. Press cells and tell it that you want row, column, and total percentages. And press continue. And okay. Okay. So you get a lot more information. Now your chi-square, your p-values, that's all still the same. You're just kind of getting some more information to help you understand stuff. This is one of those charts too that I have to like sit down and think through every time, make sure I'm reading it correctly. Kind of like the post hoc tests. Okay, so let's go across. So here's our females. Okay. So within gender, okay, there's the counts that we had before. Remember that? So we have 12 females who were in treatment for 3 months. So within gender, that's 28.6% of the females. Okay. Of all the females, 28.6% were in treatment for 12 months. 33% were in treatment for 6 months, and 38% were in treatment for 9 months. Okay. Now, within treatment length, so of the people who were in treatment for 3 months, 37% of them were female. Make sense? So again, that's why, I mean, I have to think through it every single time, so I don't.
A majority of were completed the 3-month. Within the male group, the majority of males completed 3 months. That would be correct.
So the majority of people in the 3-month length were males. Okay. So if you think about it, what you'd be looking for if this were significant, it's very similar to those ANOVA tables that we were doing with a factorial ANOVA. You're looking for different patterns. So if we look across gender, for example, we have 28, 33, 38. And across males, we've got 35, 35, 29. It's not all that different. Basically, there's about a third. Within gender, there's about a third in each. Okay, roughly. If it were significant, we would see something very different. We'd see maybe like, for females, 10, 50, 40. But for males, 40, 50, 10. Like a different pattern in the way it breaks down. Does that make sense? Yeah, so when it's a small table like this, then yeah, you can pretty much just report the pattern. But when you have a bunch of levels, then there are some follow-up analysis kind of things you can do to look at it. Yeah, it appears that females stayed in treatment, in general, females stayed in treatment significantly longer than males. Yeah, I would probably then put this table, you can't just with APA format, you can't ever just cut and paste tables from the SPSS output because they're not in APA format. So yeah, whoever's going to get their job with SPSS to make the language the same as the textbook, go ahead and put the tables in APA format for us so we can just cut and paste them into our papers. Because they're not. Every time you do a table, you have to recreate it. You have to you have to go to the APA book, type up your table, and cross. Thank you.